Imagine lying on an operating table, staring up at the ceiling, and realizing the hands about to hold the surgical instruments aren't entirely human. That sounds like science fiction, but in China, researchers are already teaching robots how to perform some of the most delicate tasks in surgery. Not walking, not lifting boxes in a factory, cutting, suturing, and manipulating tissue with a precision that used to belong only to trained surgeons. So what can these robots actually do right now, and how close are they really to operating on an actual human being? The answer is more surprising than you might expect and more complicated. Let's start with why this is so hard in the first place. Surgery looks simple from the outside: a pair of hands, some instruments, a steady rhythm. But underneath that calm exterior is one of the most demanding physical skills a human being can learn. A surgeon isn't just moving a tool from one point to another. They're making split-second adjustments to tissue that shifts and resists. They're controlling force down to fractions of a newton. They're coordinating multiple instruments at once, often through openings smaller than a coin. And they're doing all of this while making decisions under real pressure, because a single miscalculation can cause serious harm. That combination, extreme precision, constant improvisation, and zero tolerance for error, is exactly why surgery has remained one of the last frontiers robots haven't been able to fully conquer. Robots are good at repetition. Surgery is anything but repetitive. Now zoom out for a moment, because this story doesn't start in an operating room. It starts with China's enormous push into robotics and artificial intelligence. Over the past several years, Chinese labs and companies have been racing to build humanoid robots, industrial robots, advanced computer vision systems, and automated manufacturing lines. But increasingly, the goal isn't just to show off a robot that can walk across a stage or do a backflip. It's to make robots genuinely useful in messy, unpredictable, real-world environments. And there may be no environment more unpredictable or more consequential than the inside of the human body. That's where the real story begins. In recent years, researchers in China, including teams working with laparoscopic surgical robots, have demonstrated systems capable of performing specific surgical tasks with a striking level of autonomy. Some of this work has taken place in laboratory settings using simulated tissue. Some of it has gone further into preclinical experiments involving animal models, testing whether a robot can suture, manipulate tissue, or complete a surgical maneuver with results that rival a human surgeon's. Let's be very clear about what that means and what it doesn't. This is not a robot walking into a hospital and independently operating on a patient. It's something narrower and honestly more fascinating. Robots learning to master the physical building blocks of surgery piece by piece in controlled conditions. Think of it less like a graduation and more like the early years of surgical training, except the student is a machine. So how does a robot actually do this? Picture threading a needle while wearing thick gloves. Now imagine doing that inside a human body through a tiny incision using a camera instead of your own eyes, and knowing that a single sudden movement could cause real damage. That's the challenge these robotic systems face every time they pick up an instrument. Underneath the surgical drapes, it comes down to a handful of core technologies working together. Cameras and computer vision let the system see inside the body in real time. Robotic arms translate movement, often shrinking large motions into tiny, controlled ones, far more stable than a human hand. Sensors track force and position so the robot knows exactly how much pressure it's applying. And increasingly, AI systems are layered on top, helping the robot recognize anatomy, track instruments, and predict how tissue will move next. But here's the part people often get wrong. None of this automatically means the robot is deciding what to do. There's a real difference between a robot that's remotely controlled by a human surgeon, a robot that's AI-assisted but still supervised in real time, and a robot that's making independent decisions on its own. Most of what exists today lives in that first and second category. The AI might help the system recognize a blood vessel, stabilize a shaky movement, or anticipate how tissue will react. But a human is still very much in the loop, watching, correcting, and ultimately responsible for what happens next. So, why is China pouring so much effort into this? Part of the answer is demographic. China has a rapidly aging population and a growing demand for complex medical procedures. Part of it is geographic. Highly skilled surgeons tend to concentrate in major cities, leaving rural and underserved regions with far less access to specialized care. A mature robotic surgery system paired with high-speed networks could one day allow an expert surgeon in Beijing or Shanghai to guide or even remotely assist a procedure happening hundreds of miles away. That vision hasn't been fully realized yet, but it's the destination researchers are working toward. And there's a real advantage robots could bring to the table. Unlike human hands, they don't get tired. They don't develop a tremor after hours of standing. Their movements can be extraordinarily consistent, repeated the exact same way every single time. That kind of precision is hard for even the most skilled human surgeon to match over a long procedure. But don't mistake any of this for robots replacing doctors. The more realistic future looks like partnership, a surgeon making the critical judgment calls, while a robotic system handles the physically demanding, high-precision execution. Because here's the enormous problem nobody has fully solved. Human bodies are not predictable. Tissue isn't metal. It stretches, it shifts, it bleeds. No two patients' anatomy is identical. Something unexpected can happen in seconds, and a robot has to be ready for the version of surgery that doesn't go according to plan. A system that performs flawlessly in a lab, or even in an animal model, can still run into enormous challenges once it meets the sheer variability of real human patients. That gap between performing a surgical task and safely completing an entire operation without human intervention is enormous. Closing it will require years of clinical trials, regulatory approval, rigorous safety validation, and hard ethical questions about consent and accountability. A robot making a mistake on a factory floor is a problem. A robot making a mistake inside someone's body is something else entirely. Zoom out one more time and you start to see the bigger picture. China's surgical robotics research isn't happening in isolation. It's part of a much larger shift where robots are moving out of demonstrations and into real environments: factories, warehouses, hospitals, even homes. Surgery just happens to be the hardest test imaginable. So, are we about to see hospitals filled with robot surgeons? Not yet. But something has quietly changed. Robots are no longer being trained only to walk, lift, or assemble. They're beginning to learn the kind of precision, dexterity, and judgment that surgery demands. The question may no longer be whether robots will enter the operating room. The question is how much of the operation we'll eventually trust them to do, and how soon we'll be ready to find out.